So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic rectilinear acceleration. So in short, to state at the end of this video, let's go ahead and consider the first question here. It says, the slope of a straight line velocity time graph represents A, work done, B, total distance traveled, C, uniform speed, D, uniform acceleration. So guys, the answer to this question is option D, uniform acceleration. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 2. It says, the two positions of a body undergoing a uniformly accelerated motion are 10s, 10 meter per second and 30 seconds, 50 meter per second on the velocity time graph. Calculate the magnitude of the acceleration of the body. Okay, right, guys, if we use these points here now to make the calculation, let's recall that acceleration is change in velocity over time here. So guys, the change in velocity here is 50 meter per second minus 10 meter per second, and that's 40 meters per second, and this will be divided by the change in time. That's 30 seconds minus 10 seconds, that's 20 seconds. So guys, if we divide 40 meter per second by 20 seconds, we are going to have 2 meter per second squared, and that's option D here, guys. So that's it for this question. 2 meter per second squared is the acceleration of the body. Let's go ahead and consider the next question, guys. So guys, the next question here says, a ball P is released from the roof of a building at the same time as another ball Q is thrown vertically upward from the base of the building. Which of the following statements is correct? A, the acceleration of P is greater than that of Q and both are in the same direction. B, the acceleration of P is equal to that of Q and are in opposite directions. C, the acceleration of P is less than that of Q and both are in the same direction. D, the acceleration of P is equal to that of Q and both are in the same direction. Alright, so guys, for this here, the answer to this question is option D. The acceleration of P is equal to that of Q and both are in the same direction. So guys, if we throw this other ball vertically upwards, it will be limited by the resistance of the gravity. So the force of gravity tends to pull it down, and up to the point it starts coming down with the same acceleration that the initial ball P was thrown down with. So in that case, the acceleration of P and Q will be the same and in the same direction. So option D is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says, two objects A and B accelerate from rest at uniform states. B accelerates twice as much as compared to A. B travels. Alright, so guys, the answer to this question will be option C. That's 2 times as far. So if B accelerates twice as much as A, it will actually travel 2 times as far. So if we want to verify this using the equation of motion here, S is equal to UT plus half AT squared. So if the two objects are accelerating from rest, that means the two objects will actually have initial velocities of 0. So UT cancels out. So in that case, for object A, S for A is equal to half AT squared. That's for A here. And then for B as well, S for B here will be 2 times half AT squared. And that's because it's actually accelerating 2 times that of S. So half of 2A squared. That's what it is. So actually 2 cancels out with half here for object B. So in that case, object B can be seen as s is equal to at squared. Whereas option for the object A, it's seen as s is equal to half at squared. In that case, it means that 2s for object A is equal to at squared. Then object B, s is equal to at squared. So since 2s for object A is equal to 80 squared and s for object B is equal to 80 squared, it means that 2s for object A is equal to s for object B. In that case, object B as s is equal to 2s of object A. So in that case, it travels twice as far. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 5. It says, a body accelerates uniformly from rest at 2 meters per second squared. Calculate its velocity when it has traveled the distance of 9 meters. Alright, so guys, in order for us to answer this question, we'll use the equation v squared is equal to u squared plus 2as, where u squared is the initial velocity squared, and actually the initial velocity is 0, so 0 squared is still 0. In that case, v squared is equal to 2as. So acceleration here is 2 meters per second, so the distance s is actually 9 meters. So 2as is actually 2 times 9 times 2, and that's 18 times 2, so that's 36. So in that case, v squared is equal to 36, so v alone will be square root of 36, and that's 6 meters per second. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 6. It says, a car take off from rest and cover a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. So guys, for this question here, we are going to calculate the magnitude of the acceleration of this car here. So if we employ the formula s is equal to ut plus half at squared, we are going to have the distance s as 80 meters, then the initial velocity here is actually 0, so in that case ut can cancel out, so s is equal to half at squared, so s is 80, then a is not given, and that's what we are looking for. So in that case, that will be t squared is actually 10 seconds squared, and that will be times a half. So in that case, that's 10 squared a over 2. So it means that 80 meters is 10 squared a over 2. So in that case, if we make a the subject of this equation, we are going to have that a is equal to 2 times 80 over 10 squared. So in that case, 2 times 80 is actually 160, and then when we divide it by 10 squared is actually 100. So 160 over 100 will be 1.6 meters per second squared, and that's option A here, guys. Let's go ahead and consider the next question. So guys, the next question we have here is question number 7. It says, the time rate of increase in velocity is called A, momentum, B, acceleration, C, speed, and D, force. So guys, the answer to this question is option B, acceleration. So that's it for this question. Let's go ahead and consider the next question, guys. Alright, so guys, the next question we have here is question number 8. It says, A body starts with an initial velocity of 20 meters per second and moves with a uniform acceleration a for 15 seconds. Which of the following equation represents the distance s traveled? So guys, actually the distance traveled is equal to s is equal to ut plus half at squared. So in this situation, a is the acceleration and no value is assigned to that, so it still remains a. The s is the one we are looking for here. Other values are given, like u is 20 meters per second and t is 15 seconds. So guys, ut is 20 times 15 and that's 300. So ut is 300, then that is plus half 80 squared. So t squared is 15 squared, which is 225. So 225 times a is 225a, and half 225a is 225a over 2. So in that case, this will be 300 plus 225a over 2. So s is equal to 300 plus 225a over 2. And that's option C, guys. Let's go ahead and consider the next question. So guys, the next question we have here, question number 9, says, which of the following velocity time graph does not represent an accelerated motion? So guys, the one here that does not represent an accelerated motion is option C here, because there is no increase in velocity with time as the time increases. So in this case, the velocity remains the same over the time, and as such, the graph does not show any acceleration. So that's it for this question. If there is no change in velocity over a period of time in a graph, it means that there is no accelerated motion, and option C here represents this. So let's go ahead and consider the next and last question, guys. So guys, the next and the last question we have here is question number 10. It says, a moving object is said to have uniform acceleration if its a. speed is directly proportional to time, b. velocity varies inversely with the time, c. velocity increases by equal amounts in equal time intervals, d. displacement decreases at a constant rate. So guys, a moving vehicle is said to have a uniform acceleration if the velocity increases by equal amounts in equal time interval. So that's option C, guys. Here option C is the answer to this question, and that's it for this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below and we'll be sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.